Chapter 2, Lesson 1, Advanced Algebra. We've been looking at relations and then looking at special relations called functions. We want to take a look at some more characteristics of functions and some other ways of looking at them. Now, a function rule is a rule that expresses an output value in terms of an input value. Now, that's what the book says, and it's kind of mathematical and technical. Really what it comes down to this. When you put in a value for x, you get a value of y out. We talked about x being the domain, y being the range. X is the independent, meaning we can pick whatever value we want for x, and then y is dependent because the number I get for y depends upon what number I put in for x. So x is always independent, domains are always the independents, and then y's are the dependents because it depends upon this. Now, this expression on the right here, x plus 5, is called the function rule. That's the rule, or that's the operation that I apply to the domain value in order to get y, and that's what this means. A function rule, x plus 5, expresses the output value y in terms of, or in how I get it, in terms of putting something in for the x, or the input value. So that's basically what a rule is. So the expression on the right is the function rule. It's what I do to x in order to get the y value, or the output value. Y is the output. This is the function rule. I put something in for x and then I get y out. Now, something new we're going to do is we are going to replace the letter y with this this notation, right here, f in parentheses x, and the way we read that is we say f of x. So we could replace this expression here with f of x. In other words, I could take this y equals x, whoops, that's not very good, y equals x plus 5, and I would replace this y with f of x equals x plus 5. Now, I'm not adding anything different. I'm just rewriting this with a different notation. This is not multiplication. This is not something extra into the problem. You can't solve for f. You can't solve for parentheses x. None of that stuff. It just takes the place of the y. And the reason it takes the place of y, or one of the reasons, is if you take a look at this example here that I have on this next page. Let's say I had these values, x is 0, and I had these 4 functions listed on the left. And I asked you, if you substitute in x and you use 0, what is y? So go ahead and do that. Well, you might be asking, well, which one do I put it in? All of these are y. So how do you know which function rule I want you to use? And you really don't know because these y's are all the same. However, if I replace these y's with function notation and give one function, let's say f of x, and one is g of x, and one is h of x, and one is a of x, now I say if x is 1, what is g of x? In other words, what's the y value, g of x? Then you know exactly this is the function that I'm talking about right here. If I said x is 2, what is h of x? Then you know, oh, I'm going to put 2 into the h of x function. So function notation allows us a little bit of flexibility in dealing with multiple functions to distinguish those rather than trying to figure out which one of these we're going to put in. So again, these are just taking the places of the y values. Now, another thing that we can do with function notation is to use it to express, excuse me, let me go back here. Instead of saying x is 0, what is f of x? Instead of having to write this x is 0 out here separately, which you've done quite a bit, and we've done earlier this year, where we've given you an expression and said, okay, x is 7, simplify the expression, and then you substitute it in and simplify. Function notation allows us to do it in one step. So here we have f3. Notice this is a 3 now, not an x. 3 has taken the place of the normal x. So instead of f of x, I have f of 3. And again, mathematically that means this f of 3 represents the value of the function, in other words the y value, when x is at 3. So it's taking the place of saying x is 3. And basically in a function it takes the place of x. So what's going to happen is we're going to give you a function. Say, okay, here's a function. F of x is equal to x squared minus 3. Meaning, if you put a value in for x, you square it, you subtract 3, that will give you the y value. This is the function rule that gives me this value. Now, if I just say f of 3, remember, 3 is taking the place of x here. So, f of x is here, f of 3 takes the place of the x. So, in essence, we're substituting in the value of 3 for every x. So this is a way to do that. So, what I would suggest you do, like we talked about earlier, for every variable, I'd write a parentheses first, x squared minus 3. Then I would go back, and for every x, I'd put in a 3. And again, I would do this with parentheses because if this is a negative and you don't put it in parentheses, I guarantee you when you put negative 3 in your calculator, you're going to get negative 9, and that's not going to be correct. So put parentheses in there, and then you would simplify it. So 3 squared is 9 minus 3, so this would be equal to 6. So when I put in 3 to this function, I get out 6. And then I can do this with any value or for anything at all, really. What is f of negative 2? That means negative 2 is going to take the place of x. So again, a parentheses for the variable, minus 3. I put in negative 2. Now, negative 2 squared is 4 minus 3, which is 1. And again, all that means in here is this takes the place of x. And you can do it with anything. I could do, what's f of cat? Well, what does that mean? That means wherever there was the letter x, I'm going to put the word cat. So parentheses for my variable, squared minus 3. This is then cat. Substitute that in, which then simplifies to cat squared minus 3. I can't do anything else with it, so I would just leave it. So this function notation is another way to say evaluate the function at that number, meaning just substitute that value, whatever it is, and put it in for x. Okay, so that function notation allows us to do that as well.